Okay, let's get into this about water and solutions. Talk about water and all that fun stuff with that. As always, I will typically not answer the questions unless I feel it is beneficial for you or the lesson or whatever. Otherwise, the questions I'll have you do that on your own and all the video stuff. So let's get into this about water and talk about some fun things with water. So first one, I will answer this. Which type of bond or force is primarily responsible for the attraction between water molecules? That is hydrogen bonding. So let's review what it is. Water molecules are attracted to each other by hydrogen bonds. Hydrogen bonds are the strong intermolecular forces that occur between a hydrogen atom that is bonded to nitrogen, oxygen, or fluorine, or another nearby atom. Hydrogen bonds, H2O. Think of it like that, H2O, 2 hydrogen, 1 oxygen, hydrogen bonds. Video will have you do this on your own. Properties of water. So let's talk about properties of water here. We have solid, liquid, gas. So water will exist in all three states, solid, liquid, and gas. Now, as you can see, we have water vapor, ice, and we have just regular old liquid water. Fun stuff. Density. So the graph shows how density of water changes with temperature. So we notice that the density of water is almost exactly 1 gram centimeters cubed at 4 degrees Celsius. Not quite freezing yet, but just very cold. So the original definition of the gram was based on this property of water here, okay? You get that little line going on. So notice that the water is at its maximum density here. Interesting, when water changes to ice, its density drops sharply. Most liquids will become denser when they freeze. Interesting, because as a liquid freezes, it becomes a solid, it becomes like think no, because water wouldn't really work in this example. Think of like, okay, if maybe frozen pop. Let's use frozen pop. Frozen pop becomes like a solid brick. And it becomes denser because the molecules are closer together, they're tightly packed. Water is different, which is weird because you would think it would have the same type of properties as it turns to ice. However, the water molecules in the ice arrange themselves to form a crystal in such a way that they take more space than the molecules in the liquid state. So it's just a unique property of water that makes ice less dense than liquid water. Pretty interesting because it's usually the other way around. Okay, so here we have ice floats. Have you ever noticed that when you have like a glass of water that has ice in it, or maybe you're at a restaurant that has pop and you order like a Coke or something and it has ice in it, you notice that the ice is floating. Well, now you know based on water, like when it's ice or in a solid state, it is less dense. Pretty interesting. Ice blankets. Because ice is less dense than water, it floats. So that's why, again, ice cubes in a glass will float. Wild. Dense water. Okay, so cold water. Water can't, at the bottom of a lake, the water cannot get colder than 4 degrees Celsius because the water is at its densest there and a higher density matter sinks. Okay, so if the water was any warmer or colder, it'd become less dense and flows. So the deepest water never freezes. Think like a bottom of a lake. I don't know if you've ever been to Lake Superior way up north, kind of the same concept because the water is super cold, but it's not freezing at the bottom because, well, it's at its densest there. Pretty interesting about water. This doesn't apply to other things, just a unique property of water, which makes water very interesting. Okay. Well, there's some more examples of water. Okay, so now we have our bond here with water, 2 hydrogen, 1 oxygen makes water. And we have the strong polarity of the covalent bonds in water. So we have a covalent bond here. It enables the water to dissolve in many other substances. We use water for everything. Solvent. A substance, commonly a liquid that can dissolve another substance. Well, water is certainly pretty special. Polar molecule. A molecule that has a positive side and a negative side resulting in a polar bond. Water has a polar bond. Fun fact. Right, which properties describe water? Let's talk about this. Strong surface tension, it has a covalent bond. Denser as a liquid, remember that water is denser as a liquid. Unusual, unique property to water. Everything else is usually denser at the solid form like this, but water is unique, and water is a polar molecule or polar. If you need help remembering that, think North Pole, South Pole. Water's there, ice, snow. So water is a polar substance with a strong surface tension, and it's denser as a liquid than as a solid. A water molecule consists of a hydrogen atom covalently bonded to two oxygen atoms. So think a hydrogen atom, H2O. So then in each molecule of water, you have two hydrogen atoms bonding to oxygen atoms. So just like this, H2O. Now here, you'd have two oxygen atoms. So this is what we have a little typo here on our tutorial. This two oxygen atoms. Now, if yours more than one molecule of water, then you'd have two oxygen atoms because of two molecules of water. But just remember, this is a little typo right there. Solutions. Okay, here's a shower head. Now, let's see, build up on the shower head right here. The material forms because tap water has more than just water molecules in it. Tap water has other stuff in it, other minerals. So this is why there'd be buildup. Now, it isn't really, it's just crusty material. It's not really as gross as you would think it is because they're just other minerals, calcium, other minerals deposited in water. Okay, a solution. And we've already talked about this in one of my mini lessons. If it's confusing, I recommend that you go back to, you refer back to the solution lesson I did, and I showed how sugar dissolves in water. So a solution is a mixture of substances with a uniform composition, a homogeneous mixture, meaning that it can mix together and it looks like the same thing. Heterogeneous would be two different things, and you can clearly see what's going on. Solute, a substance dissolved in a solution. Dissociation, the separation of ions as an ionic compound dissolved. Okay. All right, we got some examples of, let's see, Na, sodium here, and what is going on. Temperature. Some factors that affect how quickly a solute dissolves. Temperature, when a substance is heated, the average kinetic energy of the particles increases. Okay, so meaning that it could dissolve, it breaks the particles more quickly, and they can dissolve a little bit faster. So that's why making tea, the tea bag would dissolve faster. Surface area. Surface area is a measure of the surface of a 3D object. When a solute has more exposed surface area, more particles of the solute are simultaneously in contact with the solvent. So with sugar cube, it's in a solid form. Stirring or shaking, that can also help something dissolve because you're stirring up the mix, shaking it, having the particles dissolve. Okay, we'll have you do the question on your own. Solubility. Some more examples. Salt is used to de-ice the robes in the wintertime. I'm sure you've seen this before. These questions, I'll have you do these questions on your own. Skip to this, we'll skip that video. Nonpolar molecules, for an example. A molecule that does not have a positive side and a negative side. They don't have either. Oil and water don't mix because oil molecules are nonpolar, water molecules are polar. If you have oil at home, you should try this experiment. I'll show you a little lesson as well because it's pretty cool. Get a glass of water, put a little bit of oil in it, and you'll see something like this occur. Now, if you have if you've ever seen a lava lamp before, it has the same concept because oil and water don't mix and it produces like a cool looking display. So you should definitely try this at home. Okay, let's go to the next slide. Okay, this is just showing different things. Here's carbonated drink. They contain dissolved carbon dioxide gas. So that's like sparkling water or pop or something like that. They contain dissolved carbon dioxide gas. Pretty interesting. All right, we'll skip the question. Measuring concentration. Concentration, the amount of a solute in a given amount of a solvent or solution. Okay. Molarity, the concentration of a solution measured in the moles of a solute per liter of solution. Molarity, okay. Shows an example how to measure something. Here is the formula for it and how to solve and what you would need to do. And dimensional analysis is a way that in which you would cancel certain things out for the final measurement M. Oh, okay. Now here is just another example of the formula that you would use and how to use it. Okay, questions. I'll have you do these questions on your own. I'll probably create a little mini lesson based on this formula too, because it would be pretty helpful to have just a simple lesson on that. Okay, concentration of a solution. I'll have you answer these questions on your own. And that's about it with this tutorial. Hopefully that gives you a better understanding of water. Be on the lookout for another mini lesson on just water too.